In today's lecture, we are going to discuss about collection of ward-wise population of Mysore City, linking of population data with ward polygons, symbology and data classification methods. The population information of entire India is available in the Census of India website. Thus, I open Census of India website. There I click on Census Digital Library tab. It opens a new page. There I click on Tables followed by selection of census year as 2011. On the list of bulletins, I click on Primary Census Abstract. In the opened subclass, I click on Primary Census Abstract Total. Immediately, a new state selection tool is opened. In it, I select Karnataka. As Mysore is located in Karnataka state, I selected Karnataka. Now we can see on a new page, district-wise information of Karnataka is available. Look at the name of districts at the right side of each serial number. Mysore is not available in the first page. Thus, I click on second page. Here also it is not available. So I click on third page. Now we can see Mysore at serial number 24. Click on Primary Census Abstract Total of Mysore. A new Excel file is downloaded in my system. I open it to see the information. If you get Enable Editing warning on the Excel sheet, click on Enable Editing button on the Excel. Look at the information. Here we have information for entire district. But we need population information of only Mysore wards. By moving down of Excel rows, I can see ward information of Mysore City. It starts from row number 755 and ends at row number 819. We need information of only these rows and other rows should be deleted. To select the rows top of 755, except the first row where the heading of information is available, I select number 2 on the Excel sheet by clicking on number 2 on row index number. Then I move to row 754. By pressing Shift key on the keyboard, I click on number 754 on the row index number. As we have already selected row 2 at the top, the row from 2 to 754 is selected. Now right click on row index number and click on delete. In the same way, I am going to delete the rows below the Mysore ward. Look at the columns. There are few columns which is not necessary for our work, such as state, district, sub-district, town or village, ward, EB and level. Thus, it can be deleted. To delete it, right click on the index number of column followed by a click on delete. The name field represents the number of wards. Thus, I would like to change as ward underscore number. As well as instead of having the lengthy default name in the cell, I would like to change it with simple number as 123. So I type the numbers using keyboard. Now we can see a green flag on the left top of the cell. It indicates numbers are stored in text format in the cell. To change this as number, select a cell and click on the warning icon at the right side of the cell. On the drop-down list, click on Convert to Number. We can convert the cell one by one or select all the cell and convert all together. Look at the columns. The second column, which is TRU, which stands for Total, Rural and Urban, is not necessary for us. Thus, I right click on the column index number and delete it. Look at the column name. The column names are mentioned in short form with underscore. The full form of this column's name is shown here. You can take the screenshot of it for your future reference. Now open the QGIS and open the attribute table of watts. Here we can create a new column and enter the population information. If we need to enter all the population information in attribute table, which is 86 columns of 65 word information, it may take long time as well as there are chances to make mistake while entering data. Thus, this data can be linked with attribute table join option in the software. To perform it, the population data should be saved in CSV format. The CSV stands for comma separated value file format. To save this as CSV file, go to File and click on Save As, then go to your folder, write a name as pop_mys, which stands for Population Mysore, and change the file type as CSV and click on Save. Look at the first column where we have saved the ward number, and this column is going to be used for joining table. Close the Excel. To add the population from CSV to ward attribute table, the CSV file should be opened in project. To open it, click on Layer on the menu bar and click on Add Layers, followed by a click on Add Delimited Text Layer. On the pop-up window, click on Browse button at the right side of file name. On the new pop-up window, select your CSV file followed by a click on Open. Click on the arrow of file format and make sure CSV option is selected. Click on Records and Field option. Make sure first record has field name and detect field types are selected. In geometry definition, no geometry should be selected. And under the layer setting, nothing is selected. The table information can be seen under sample data. Click on Add followed by a click on Close. Now right click on the watts layer in Layer panel and click on Properties. On the pop-up window, click on Join tab in the left panel. Then click on green color plus icon, which is Add New Join. On the new pop-up window, at the join layer, pop_mys is already selected as we have opened that on our project. Select ward number at join field because it is the column in which we have saved the ward number in CSV file, and select ward number as target field. Now click on OK. Now we can see a new row information on the join window. Open the information by clicking on the black arrow at the left side. It provides the information of table joined. Click on OK. Now right click on watts in layer panel and click on Open Attribute Table. We can see all the population information from CSV is joined with our ward layer. The table what we have joined is temporary. If we remove the layer from the project or if you close the project, the table link will be disconnected. So to save the information permanently, right click on the watts in layer panel and click on Export and click on Save Feature As. On the pop-up window, make sure format is ESRI save file. If something else is there, change into ESRI save file by clicking on drop down option. Click on the browse icon at the right of file name and save it in your specific folder. In my case, I am saving this in Mysore folder in the name of mys_pop_data, which stands for Mysore population data. Make sure your CRS is assigned with correct projection coordinate system and click on OK. Now, new saved file is opened on window. Right click on new saved file and open the attribute table to confirm all the population information is available. Remove all the files except Mysore population data. Now we are having polygon of all 65 wards of Mysore City as well as population information of each ward in the attribute table. Using this information, we can classify the wards into 3 groups. To do that, right click on the Mysore population data layer in the layer panel and click on properties. Then click on symbology tab in the left panel. Look at the single symbol on the top. Click on the down arrow at the right of it. Now we can see few symbology options. The first one is no symbol. When I use the no symbol, we can see all the data on the canvas is hidden. So no symbol generally doesn't give any symbol to our data. The next one is single symbol. This symbology is used to represent the entire data in a single color. The third one is categorized. It is used to symbolize unique values in our data. For example, if I select the ward number in the value field followed by a click on classify, we can see each ward is assigned with a unique color. The fourth one is graduated. It is used to classify the data into different groups. The fifth one is rule based, which is used to create custom rule based symbology for our data. The next one is inverted polygon, which allows a feature polygon to be converted into a mask. The final one is 2.5D, which is used to visualize the data in near to 3-dimensional. Among the several options, we have to use graduated to classify the Mysore ward population into 3 groups. So I select graduated, followed by selecting the value here as pop_mys_to, because it is the column where the total population of each ward is stored in our attribute table. Look at the right bottom of window. Here we have the option called classes. Here we have to mention how many classes we have to classify. The default value is 5. If we want to increase it, we can click on the top arrow to increase it. If we want to decrease it, we can click on the down arrow to decrease it. In this case, we need 3, so I make it into 3. Now look at the mode. Here we can see different classification method of data. The first one is equal count, which is also called as quantile. The second one is equal interval. The third one is logarithmic scale. The fourth one is natural breaks. The fifth one is pretty break. And the final one is standard deviation. We will see these classifications in detail. Data classification methods. When we classify our data, we can use one of the many standard classification methods provided in QGIS, or we can manually define our own custom class ranges. Equal count or quantile method. Each class contains an equal number of features. A quantile classification is well suitable for linear distributed data. Quantile assigns the same number of data values to each class. There are no empty classes or classes with too few or too many values. Because features are grouped into equal numbers in each class using quantile classification, the resulting map can often be misleading. Similar features can be placed in adjacent classes, or features with widely different values can be put in the same class. We can minimize this distortion by increasing number of classes. Now we will define equal count classification to our data with 5 classes. After defining equal count in mode, I choose 5 classes and click on classify button. followed by a click on OK. To see the number of wards in each class, I right click on the layer and click on Show Feature Count. Now we can see all the classes are having 13 polygons of total 65 polygons. The polygons are equally classified into 5 groups. Now I will change it into 4 classes and see the output. 3 classes are having equal number of 16, while 1 class is having remaining 17 polygons. As this 17 cannot be divided into 2 equal 16s, the remaining 1 polygon is added with 1 group. Equal interval method. Equal interval divides the range of attribute values into equal sized sub-ranges. This allows us to specify the number of intervals, and QGIS will automatically determine the class breaks based on the value range. For example, if we specify 3 classes for a field whose values are ranging from 0 to 300, the application will create 3 classes with ranges of 0 to 100, 101 to 200 and 201 to 300. Now we will define equal interval to our data in QGIS with 5 classes. Look at the number of ward polygons in each class. It differs from one group to another group because it classifies the data in the attribute columns irrespective of number of polygons. Logarithmic scale method. A logarithmic scale is a way of displaying numerical data over a very wide range of values in a compact way. Typically, the largest numbers in the data are hundreds or even thousands of times larger than the smallest numbers. Now we will define logarithmic scale to our data in QGIS. Look at the classification. The values of logarithmic calculated and it is classified with equal interval. And look at the number of polygons in each classes. It is entirely different from number of polygons classified in the group of previous methods. Next one is natural breaks method, which also called as junks. Natural break classes are based on the natural groupings characteristics in the data. Class breaks are identified that best group similar values and maximize the difference between classes. The features are divided into classes whose boundaries are set where there are relatively big difference in the data values. Natural breaks are data specific classifications and not useful for comparing multiple maps built for different underlying information. Now we will define natural break to our data in QGIS with 5 classes. Look at the classification. It provides a different result than previous classification. The next one is pretty breaks. If we want round numbers in our ranges, then we should choose pretty breaks. All pretty breaks rounds each break point up or down. Now we will define pretty break to our data in QGIS with 5 classes. Look at the classification result. The data is classified into 5000 interval with round numbers. Standard deviation method. The standard deviation classification method shows us how much features attribute value varies from the mean. QGIS calculates the mean and standard deviation. Class breaks are created with equal value ranges that are a proportion to the standard deviation. Now we will define standard deviation to our data in QGIS. Look at the number of polygon or number of wards in each classes. It is entirely different from the classification result of previous methods. The final one is manual interval. If we want to define our own classes, we can manually add class breaks and set class ranges that are appropriate for our data. To define manual interval, we can start with one of the standard classification method available in the software and make adjustments as needed. For our better understanding, I have prepared maps using default classification method available in the software and shown here. The top 3 maps are classified into 3 groups using default classification method available in the software, such as equal count, equal interval, and natural break. And the bottom maps are classified into 4 groups using logarithmic scale, pretty breaks, and standard deviation. Look at the above 3 maps. Area is same and the data what we have used is same, but our results are different due to the different classification method. If we consider first value in the legend as less populated wards, second value in the legend as moderately populated wards, and third value in the legend as a highly populated wards, we end up with 3 different results. Look at the 3 maps below. As these 3 classification methods are not supporting to classify the values into 3, I have classified it into 4 classes. Here also we are facing the same problem. We assume that if the City Urban Development Authority of Mysore wants to allocate fund of 10 lakh rupees for each highly populated wards, the result of equal count will get 2 crore 20 lakh for the city as there are 22 highly populated wards. But in the case of equal interval and natural break, it will be 50 lakhs and 70 lakhs. Hence, it is recommended to do pre-analysis of your data with different classification method to obtain the correct result. In this training program, we are going to use manual classification method to classify the wards population into 3 groups. To decide the class interval, first we look at what is the range of population data in attribute column. So I open attribute table and click on population field name. It provides the ascending order of population. The minimum value is 7028. Again I click on the column name. It shows the values in descending order. The highest value is 31,616. We will classify this as the wards which is having population of less than 10,000 is considered as low populated wards, and the wards which are having population between 10,000 and 20,000 are moderately populated wards, and the wards which are having the population more than 20,000 is considered as highly populated wards. First we will select any available classification method and define the class as 3. In this case, I am going to select graduated symbology method and equal interval data classification method. And I define number of classes as 3. Now we can see the system classified classes on the pop-up window, but we have to define our own classes. To do that, double click on the values of higher class. On the pop-up window, we see the higher value of our data range in upper limit. Do not change it, leave it as it is, and change the lower limit as 20,000, followed by a click on OK on the pop-up window. See the upper limit of second class. It was changed after we have defined the lower limit of higher class. Now double click on the values of second class and define the lower value as 10,000, followed by a click on OK. Look at the upper limit of first group. It is changed automatically as 10,000. If you want to change the color of our result, click on the down arrow of color ramp and change it. To add the class name in the legend, I double click on higher value of legend, which allows me to edit the class values. Here I type high and keep the values inside of bracket. Then I double click on second label and do the same, followed by changing the first legend. Once it is over, click on OK and look at the map on canvas. Recap of today's lecture. We have discussed about how to collect population of wards in Mysore City, how to link census data from CSV file to attribute table, what are the default symbology and data classification methods are available in QGIS, and how to define a classes manually. To know more about QGIS software, visit www.qgis.org.